Hello, everybody. Happy Tuesday. I hope we're all very excited for the class today. My name is Maeve. I am the Irish Whiskey Brand Ambassador here at Pernod Ricard. I have been with Pernod Ricard for the last 2 years, getting a chance to work for them in Bangkok, Thailand, representing our Irish whiskies, and now over here in the States. While you might have already clocked from my accent, I am from Ireland. I'm from a place called County Clare, about 3-hour drive from Dublin, if that's the landmark you have in your head. But I am over here now in the States, based out of Dallas, Texas, and I do get to run around quite a bit. So hopefully at some point I'll encounter a few of you in the bars that you interact with. And if I do, make sure you come and say hello. I am joined by two very special guests today. The man, the myth, the legend, and also our master distiller, Kevin O'Gorman, is here. And then we also have our tutor at the Irish Whiskey Academy, Tommy Byrne. Tommy actually was my tutor just over 2 years ago and made me the expert I am today. So I'm so excited that you are getting the same chance. For anybody who's new here, maybe listening in, maybe beside a friend who's listening in, if you don't know what's going on, I am here to tell you just that. Portland Cocktail Week has teamed up with the Irish Whiskey Academy and Jameson Black Barrel to produce an Irish whiskey certification virtually. And today is our second public class. We also do private classes throughout the weeks, and we are really, really diving into the nitty-gritty world of Irish whiskey. Today we are getting deep into distillation. If you are here and you're thinking, I'd love to get in on this, maybe get in on the private class, maybe be actually able to complete the certification, well, it's your lucky day that you showed up, because we have reopened our application process for the spring cohort. So it closed tonight at 11:59 Eastern time. So make sure you head to pdxcw.com at Irish Whiskey Spring and put in your application. Spend some time on it, because we are selective, but we're introducing 50 bar industry people to come and complete the program. So tonight is the last time to apply. But back to what we are here for today. This class is a comprehensive class that's going to delve into the raw materials that is used in the production of Irish whiskey. We are really, really focusing on the fermentation and the distillation process that makes the artistry, the craft, and the tradition of Irish whiskey alive, and so that you'll understand it just that little bit more. Before we get into it, I have a few call to actions, just some things so that you can stay in the know about what's going on. We have so much exciting things coming down the pipeline, and we want you to get involved. So make sure that you are liking us on Facebook, subscribe to our YouTube channel, follow us on Instagram, and of course, this is a two-way conversation, whether it feels like it or not. Make sure you get those comments in the comment box. Ask questions, give your opinions, let us know what you're thinking. And that's extremely important for the 50 people who are participating in the certification course, because that is how we are going to mark you present. So make sure you say hello, ask a question, or give us an opinion, because we want to hear from you. But other than that, I'm going to pass you over to Kevin and Tommy to delve into this class.
Kevin, go ahead.
Tommy, do you want to go first?
Master Distiller has to go first. Go on.
Okay, hello everyone. So Kevin O'Gorman's my name. The Master Distiller here at Midleton. I've been working here for 28 years now, and I've been in the industry for about 36 years. It's an incredible place. So Tommy and I are speaking to you from the Whiskey Academy, which again has wonderful history, going back to the late 1700s, Tommy. Mm-hmm. So it's great to be here. We've some slides to go through, ask lots of questions, and Tommy, maybe you introduce yourself.
Kevin, yeah. So guys, I think probably met y'all last week, but I'm Tommy. I'm the tutor here at the Irish Whiskey Academy. Again, you're going to see me kind of over the next few weeks in the classes. Obviously, it's a real treat today to have Kevin here. So we're going to do a really deep dive on distillation today. We are going to be covering raw materials, brewing, fermentation. Don't worry. I know, like particularly the 50 who are in the private classes, you guys are going to have a lot of probably in-depth questions. We do have a class tomorrow where we're going to be going even a little bit deeper on the raw materials and stuff. So don't worry. If not everything is covered today, we'll definitely have it covered by tomorrow. But other than that, I hope you enjoy the class. I'll pass it over to Kevin.
Okay, so I'll just take the first few slides. Okay, just to start with, there's rules and regulations around the production of Irish whiskey. Originally, if you go back to the early 1980s, there was an Irish Whiskey Act, which I suppose really determined or controlled how Irish whiskey was produced. But in 2011, 2012, there was what we call a GI, or a geographical indicator, which controls and determines the production of Irish whiskey and how it's produced. So that's a really important document going back maybe 12, 13 years ago. And really it controls that, things like it has to be produced on the island of Ireland. So the Irish whiskey can be produced in the island of Ireland. It has to be made from cereals, from a mash bill of, barley, malt barley, maize, but basically cereal based. It has to be matured, it has to be produced in the island of Ireland. So there's lots of rules and regulations around the production of Irish whiskey. In terms of Irish whiskey styles produced at Midleton, I suppose there's 4 main styles. The first one on the left there is pot still whiskey. And I suppose this is the quintessential traditional style of whiskey production in Ireland, going back a few hundred years. The mash bill that we use in Midleton is a mash bill of barley and malted barley, and we'll talk about that later on. And it's triple distilled in copper pot stills, and that, I suppose, that's really a definition of what single pot still whiskey is, and it's all done in the one distillery here at Midleton. Hence the term single pot still whiskey. Okay. Then next to that we have malt whiskey. And that's made from a mash bill of 100% malted barley. Okay. Again, it's triple distilled in copper pot stills, and it's all done in the one site, hence the name single malt whiskey. In Midleton as well, we produce grain whiskey, and our grain whiskey is made from a mash bill of maize and malted barley, triple distilled in column stills. And again, I suppose the grain whiskey that we produce here at Midleton is a very fine signature style grain whiskey, which we'll go into in some detail later on. And then finally, we've what we call a blended whiskey, which is a combination of 2 or more of the styles above: pot, malt, and grain. So, for example, Jameson whiskey is a blend of pot and grain whiskey. Okay, so they're the 4 main styles of Irish whiskey. And I suppose just to give you some examples, going from my left, so we have our famous Redbreast brand, Redbreast 12 there, and that is a single pot still whiskey. And again, just to remind everybody, in Midleton, it's made from a mash bill of malted barley and unmalted barley, triple distilled in copper pot stills, matured in a range of different casks, and it's all done in the one distillery. So that's what a single pot still is. Then the second one is what we call a single grain whiskey, and this is made from, as the name suggests, 100% grain whiskey. This was a whiskey we launched a number of years ago, back in 2017, which is a single grain using from the Method and Madness brand, which really is our kind of innovative brand that we set up back in 2017. And this was one of our first launches, which is a single grain whiskey finished in virgin Spanish oak. Then we've got an example of a blend, which is, for example, Jameson Black Barrel, which is a combination of pot still and grain whiskey. And we can chat a bit about that later on. And then we have an example of a single malt that we do here in Midleton, which is a Method and Madness single malt. Again, that was one we launched a number of years ago, which has a contribution of some Limousin French oak. So they're all examples of the styles of whiskey that we produce. Okay, so any questions, maybe just put them in the chat and we can either leave them at the end or as we go, whatever suits. So pot still, let's move on to how we produce pot still or single pot still whiskey. How do we do it? So I'm going to maybe give it to Tommy here just to take an overview.
Thanks, Kevin. Yep. So, we're following, I suppose, the full kind of grain to glass journey over the course of the few weeks of the course. Today, like the main focus is obviously on distillation, but we are going to touch on all the points leading up to there. So starting with the raw materials that come in, as Kevin mentioned, like the GI is very kind of specific about how we can produce each style of whiskey, even down to the point of what grains can be used, even so detail as like the ratios of grains, that kind of thing. So we'll have a look at the raw materials, then the kind of various processes that lead up to distillation. So milling, mashing, filtering, fermentation, basically to the point where we make alcohol or create alcohol. And then when we talk about distillation, it's kind of how we refine that alcohol a little bit further. So the first, I suppose, kind of block of processes in the whiskey production process is kind of collectively termed brewing. And you've obviously heard that name before. Brewing, so as we probably more commonly associate with a beer. And I suppose really that's just showing that like whiskey does start off life as a beer. We touched on some of the history of kind of whiskey last week and how it came into being. Beer is being made for thousands of years, just a natural progression. As when the technology of distillation came on the scene, then we took it that step further. So yeah, we are going to make a beer to begin with here. Again, we're going to go a little bit deeper on the grains themselves tomorrow, but definitely have to point them out here. So we're talking about pot still whiskey. The GI is very specific in how you can produce pot still whiskey. So the two grains on the screen here, barley and malted barley, Kevin's already mentioned them. I suppose really you're thinking of that as being barley in two different forms. Barley, sometimes referred to as unmalted barley, just to distinguish the two. It's species of grass. What's kind of unique about pot still whiskey is that we do use it in its raw or unmalted form. So we just call it barley. That's kind of in the scheme of things really unique to Irish whiskey. Outside of really the craft scene, maybe in some other countries, none of the big international competitor brands are really using unmalted barley. It's what kind of sets single pot still whiskey apart. And what it's really going to contribute in the final whiskey is a really nice silky texture in the palate. Might contribute a little bit of kind of fruity spice notes as well, but really nice silky texture on the palate. And for those of you who are in the cohort who'll be doing tastings and stuff over the next few weeks, particularly later on in some of the later classes when we're trying some of the components, we'll really pick up the silkiness of the pot still whiskey. So the unmalted barley is that to thank for that big influence. The malted barley is slightly different. I suppose it's different in the sense that it's used all over the world. Mentioned last week, really important to Japanese whiskey, particularly Scotch whiskey, but very important to ourselves as well. What we do, essentially soak barley in water, basically make it nice and moist and damp. And we'll do a real deep dive on that tomorrow. Essentially make it damp. This encourages it to grow. Let it grow for about 4.5 days. That's going to create lots of sugars in the grain. Then you simply want to dry it down to stop the growth, preserve all those sugars inside. And we really kind of drove home the point last week that when you dry the grain, we're just using hot air. We're not burning any peat, commonly done in Scotland, that would impart smoky characteristics. We're not doing that. We're using hot air to dry down the grain, just preserve the natural flavor there. When it comes to the mix, roughly about 60-40. About 60% barley, 40% malted barley is what you call our mash bill, or if you want to think of it as being like the recipe, essentially. So we take those grains, we're then going to mill them, which is basically converting it from whole grains into a flour, or the term in the whiskey industry is grist. Think of it as being like a fine flour. So as main point to make here, we use hammer mills, which essentially kind of hammer the whole grain down into a fine flour. So we would mill much finer nowadays than we would have, say, 50, 100 years ago. The reason we mill finer, essentially it's efficiency. We're going to be able to extract more of the sugars and thus create more alcohol. Does create a little bit of problem with filtering that we'll talk about in a second. But essentially we mill both of those grains down separately. The stage where you mix them then is called mashing. So again, we do that 60-40 mix. We use a big stainless steel tank, essentially called a mash tun, and here we introduce some hot water. So you're making almost like a soupy kind of texture here. You're mixing in hot water, a bit over kind of 4 times the volume of hot water. So, there's a lot of liquid here, and you're stirring up that mixture. And what's happening here is enzymes are going to be breaking down any remaining starch into sugar. We want starch to be converted into sugars here. And it's going to be in there for a bit over 2 hours, just constantly stirring up that mixture. The enzymes are doing their job. What's unique about Irish whiskey is we can add extra enzymes at this stage, whereas, for example, say in Scotland, they're not allowed to do that. Extra enzymes can be used here to basically make the process more efficient. Again, it's about creating more sugars and thus creating more alcohol, making the process more efficient. But it's going to be in there for about 2 hours, stirring up the mixture. At that stage, you have this lovely sugar content, but again, it's still kind of like a soupy kind of texture. You've still got all the solids inside there, so we want to get rid of them. So what we're going to do next then is something that you may not have seen before. We're going to use what's called a mash filter. Traditionally, the bottom of that mash tun would have just had kind of like a sieve or kind of a false floor in the bottom that would collect all the solids and allow the sugary liquid to pass through. Because we mill so fine nowadays, that's not really possible. So we now use what's called a mash filter. Hopefully you guys can see the diagram there. The mash filter is made of these plates. The plate's going to have 2 sides. So it's a metal frame. You've got 2 membranes then, one on either side. One is non-porous. Nothing can basically pass through. The other is porous that allows liquid through. You can see in the diagram, you've got the plates basically tied against each other. There's an empty chamber separating the plates. We pump in that kind of soupy mash into the empty chamber, force air in behind it, and the air forces all the liquid through the porous membrane. So you're using air pressure, essentially squeeze the liquid out. And that makes it really, really efficient. We can extract over 10% more alcohol from every ton of barley using all the various processes that we use nowadays compared to, say, 20 years ago. This is a big part of it. You're squeezing out every drop of sugary liquid. So the sugary liquid that comes out is called wort. What's kind of left behind, essentially, then, of course, are all the solids. That's called draff. And just like has been done here for centuries, the draff is then basically sold as an animal feed. Really, really important byproduct from the process. Obviously reduces what would kind of be considered waste. It's obviously an income stream as well. So really, really important. That goes towards the animal feed. But what we have from the whiskey making point of view then is sugary water called wort. So, and again, if there are any questions that's relevant, just shout them through.
We have one question here. Can you give some examples of the enzymes that you're using?
Yeah, so we've used like let's like amyloglucosidase, glucoamylase. Later on, we'll talk about for the grain brewing, we've used convertase.
I suppose the important point here is that because of the percentage of malted barley that's in the mash bill, in general, we would have the idea is to have sufficient enzymes to cover the conversion. But as Tommy said, in Irish whiskey GI, we are allowed to add what we call exogenous enzymes if need be. So this supplements alpha amylase and beta amylase. However, in general, depending on the malt barley, depending on the growing season, depending on the quality of the malt barley, we would try to rely on the malted barley itself, but we are allowed to add exogenous enzymes. And they're looking for examples. Basically, you're supplementing alpha amylase and beta amylase to break down that starch. That's what you're doing.
Perfect. And we just have one more question which I think is a good one to cover. Is there a general duration of time that the grains are fermented when making the Irish whiskey?
Yeah, so we're going to look at ferment. Yeah.
Moving on to that. Perfect. Yeah. We'll leave that, so we'll get into it next.
Yeah, so right now, so essentially we have a sugary water at this stage, again, called wort. So fermentation then is where we essentially convert the sugary water into, again, what's basically a beer. So for this, we need another raw material, which is yeast. Yeast is actually a fungus. So there's thousands of different kind of yeast strains around the world, like it would be in the air outside, just naturally in the environment. We use a very particular strain though. So obviously for reasons of efficiency and consistency, we need to use the same yeast strain each time. So we use Saccharomyces cerevisiae, which I know is a bit of a mouthful. You can just call it distiller's yeast. But if you know the scientific name, you can kind of remember exactly what it does. If you break it down, saccharose means sugar, myces means fungus, cerevisiae, beer. It's the sugar fungus of beer. So basically, this is a fungus that we're essentially going to feed sugar to, and it's going to make a beer for us. That is basically the fermentation process in a nutshell. Now, you can get yeast in lots of different forms. You can get it powdered. You can get it pressed, which is kind of like a putty. We use it in what's called liquid form. Essentially, very easy to use. You don't need to, like with the powdered yeast, you have to do a lot of activation and stuff. Liquid can essentially be mixed in with the liquid wort, and there's not a huge delay in the actual sequence. So we use Saccharomyces cerevisiae in liquid form. Why we use yeast is because of this, amazing part of yeast growth cycle. Essentially, we feed it sugar, and just a natural part of its growth cycle is it's going to take in the sugar, basically consume it as an energy source. It's going to turn about half the sugar into CO2 and about half into alcohol. Again, someone discovered this thousands of years ago, and obviously we've been using it ever since. So it is a living organism. It is a fungus, so it has kind of favored environmental conditions. So this particular strain, we keep it between 26 and 32 degrees Celsius. So this is in big stainless steel fermenters. You might not really be able to make it out in that diagram there, but there's cooling coils that go around the outside of the fermenter. So we basically pump cool water from underground. There's caverns beneath the distillery that we pump up cool water. We circulate that around the fermenter. That regulates the temperature. And again, all going well, the yeast is consuming the sugar in that sugary wort, turning about half into CO2, which we vent off. And then the other half is being converted into alcohol, essentially. Now, Kevin's going to be talking a bit about distillation in a while. And like alcohol is a very broad term for essentially a lot of different chemical compounds. Ethanol, think of that as being like the good alcohol, the one we want in the final bottle. We will have trace amounts of other alcohols like methanol, and Kevin will talk a little bit more about that in a while. So the main kind of byproducts of this fermentation process, ethanol and CO2 are the main ones. We've got methanol, we've got some of the higher alcohols like propanol and butanol. Again, these will be kind of stripped out of the process. You also have esters and aldehydes. This is where you have like alcohols reacting with acids. Naturally, you're going to get lactic acid bacteria that creates acid, which reacts with the alcohols. And that's going to create kind of fruity flavor compounds. So those esters there, this is a collective term for lots of fruity flavored compounds. Some of these are going to be really, really important to us. They're going to last right through to the final product, essentially. So think of this as being the first big milestone. We've taken in our raw materials and essentially processed them now into a beer. So we have a liquid that has alcohol and flavor compounds. It's a milestone, but it's something that's going to be kind of heavily rectified from here on. We're going to keep some of those alcohols, some of those flavors, but also remove some as well. And that's where distillation comes in. So if there's any questions on fermentation, fire away. But if not, I'll hand over to Kevin.
Could you guys speak to how similar the fermentation would be to, say, a fermentation of a wine?
It's different. I mean, wine, you're dealing with grapes. You still obviously have your yeast. There would be different strains of yeast. It could be a natural yeast or it could be added yeast. But I suppose your base here, or we have mash bills, it's cereal based, it's starch based. Whereas wine, obviously, you're talking about grapes. And your yeast then works on the sugars from the grape. So you have a different base material, giving you a completely different flavor profile and different alcoholic strengths. And the pathways which Tommy spoke about in terms of all these higher alcohols, propanol, butanol, aldehydes, etc., esters, the pathways or the metabolic pathways for the yeast for wine would be very, very different to, for example, producing wash or whiskey. So they're quite different.
You tend to get a lot more methanol on the wine side. The pectin in grapes produces a lot more methanol, so it's not as much of a problem for us as it would be for, say, like maybe a brandy or a cognac producer or something. I suppose is one slight difference. And I suppose, like, we are going to distill at this stage, you know, like certain wines, you know, you're going to be fermenting in the cask. That's not going to happen with the whiskey casks that we'll be talking about next week. You know, we're putting in a distilled spirit. There's no fermentation in our casks.
Yeah. So if you take wine to its next step in terms of distilling wine, then you have your cognac, brandies, etc. So that would be the next step in terms of producing. Even with cider, you could produce apple brandy from the distillation of cider. So really, I suppose it's a very, very different process. The principles and chemistry and biochemistry, yes, there's a lot of similarities, but the final product is very different.
Amazing. Thank you so much. And just would you say that the fermentation process is like an exact science? We have a question here that's saying, are you measuring the esters and flavonoids? And if, like, say, after 80 hours, it's not where you want it, are you fermenting it longer, or how does that kind of work?
Yeah, we tend to have a pretty standard process. I mean, we have a very, I suppose, automated control process that we've built up over the last 30, 40, 50 years. So with a process like ours, once you control the inputs, and what I mean by inputs in terms of the barley, the malt barley, temperature profiles, yeast addition, all that, once you control your inputs, then you're in a very good place to control your outputs and to get a consistent output. So we don't get much variation in terms of our final wash profile. Temperature is very important because the yeast is very much dependent on temperature. If the temperature goes too high, it will kill off the yeast. So we control the temperature. During this fermentation process, there's a big buildup of temperature because of the activity of the yeast. And that's why, as Tommy mentioned, we have cooling coils on the outside to keep the temperature certainly no higher than 32 degrees Celsius. Anything higher than that, you're going to end up with a problem with the yeast. So yes, we do check the flavor profile and the profile of our fermentation, but I'd have to say it's a very, very consistent process. Even during summer here, not that we have very good summers here, but if the temperature during the summer gets up, it will put pressure on our cooling water. But because we have a sufficient supply of underground cooling water, that doesn't cause us any problem either. So I hope that answers the question, Eve.
That's perfect. We've actually two last questions that kind of cover the same topic just before we move on. If you could maybe just clarify a little bit more on the type of yeast used, if it's consistent with all Irish whiskey, or if the distiller's yeast is a specific type to the category.
Yeah, so we use what we call a distiller's yeast. It's, probably there's quite a number of distillers in Ireland that would use that particular type of yeast. We've been using distiller's yeast for, oh my God, a long, long time. Certainly since the new distillery was built in 1975. So that's what, 50 years. So we wouldn't have changed. But there's no reason why other distillers in Ireland wouldn't use that particular strain, or they might source it from different yeast suppliers and it may be a slightly different strain. So there could be variations in the type of yeast, but for Midleton, we've been using the same strain for well over, I'd say, 50 years or more.
Amazing. That's perfect. I think we're good to move on. Yeah.
So at this stage, as Tommy has described, we have what we call a wash, or I suppose you could call it a beer, at about 10% alcohol by volume. Okay, so that's where we are. So what we do is, I suppose we have to move on now to our distillation step. How are we going to take out the alcohol from that wash, which is at 10%, and we end up with a spirit at about 84%. So what are the steps we take to go from a 10% wash to about an 85% spirit? And how you do it is basically through distillation, which is the application of heat, boiling off your liquid, producing vapors, and then condensing down that vapor using water coolant and condensers. So Before we get into it, I suppose just a few things about our pots. We have the world's largest working pot stills. In terms of total capacity, they're about 80,000 litres capacity. However, our working capacity is about 38,000 to 40,000 litres. So basically half that capacity is a working capacity. Interestingly enough, the old distillery here at Midleton, which was founded in 1825 and shut down in 1975 when our new distillery came on stream. On site here on the old distillery, we have what is definitely the largest pot still in the world. I think it's about 145,000 litre capacity. So almost twice our stills at the moment.
Crazy.
And if you come to visit the old distillery in Midleton, you'll actually see that largest pot still in the world. But that's a different story. So there are stills at the moment. The shape and size of stills is really important. Obviously, in Midleton, we've kept our pot stills the same shape, the same size, going back many, many years. But if you compare our stills with stills in Scotland or America, or, for example, in other parts of Ireland, all the stills are of different sizes, different shapes. And the reason that makes a big difference is one particular important point is what we call reflux. And when I go on to the next slide and we talk about distillation, I'll chat a bit more about reflux and the importance of it. The other thing, why do we use copper? So copper has always been used for pot still distillation, and it's really important because copper reacts with sulfur compounds and forming copper sulfate, and that basically reduces the concentration of copper in the distillate. And sulfur in distillate, depending on the type of sulfur, can give a burnt, maybe vegetable note, which is really unwanted. So the control of the concentration of sulfur compounds is critical in the production of distillate. And that's where copper really comes in. And later on, when I talk about column distillation, copper also plays a huge part in the production of grain whiskey. Okay. So, in terms of stills at Midleton, we have 10, main pots for producing whiskey in Midleton. We have 6 in our garden stillhouse, and our garden stillhouse is our newest stillhouse on the main site. It was built in 2013, 2014, and at the moment we have 6 pot stills inside in that garden stillhouse. The Barry Crockett stillhouse is the original stillhouse going back to 1975, and we have 4 stills in that stillhouse. So we've 6 and 4. We've 10 pot stills on the main distillery. We also have a micro distillery which we built in 2015, 2016, and there's 3 stills in that micro distillery. They're much smaller. They have a size capacity of 2,500 litres up to 3,000 litre capacity. So they're much smaller in comparison to our main pots on the main site. We also then have 1 gin still. You can see it on the left-hand side there. So on the left, that's a beautiful gin still, which is about, I think, 70, 80 years old. It's a very, very old still. And it's in that still that we produce gin. For example, Method and Madness gin. It's a beautiful gin that we produce here. And that's what we use that still for. The middle photograph is a photograph of our micro distillery. You can see the 3 pot stills there. And then on the right-hand side, you have a photograph of the Barry Crockett stillhouse with the 4 large pot stills there. For condensing, so when you produce a vapor, when you apply heat to the still, alcohol boils at about 78 degrees Celsius. The vapors start to rise up, and then you gotta condense those vapors down, and we do it by using what we call shell and tube condensers. Traditionally, going back, 70, 80, 100 years, condensing was done using what we call a worm tub, and that basically is a copper pipe coming off the top of the still, and it's submerged in a bath or a tank of cold water, and that's how the condensing was done. Whereas now we have much more modern shell and tube condensers for doing the condensing.
So we were mentioning as well, Kevin, you were talking about the copper wear in a way that the Barry Crockett stills had to be.
Yeah, so over time, you'll have a lot of wear on the stills because of the wear and tear, the interaction of sulfur with the copper and the production of copper sulfate. So you're going to have wear and tear. So we have to repair and replace certain parts of the stills over time. And as Tommy said, back in 2000 and I think it was 18, 19, was it 20?
Yeah.
2020, we actually had to replace the entire stills in the Barry Crockett Stillhouse there on the right-hand side. So there's a lot of wear and tear. And what happens over time is the copper becomes quite thin, and it's no longer safe to operate the still due to pressures and temperature. And we basically have to replace the pot still. So I think we have a video here of the pot stills in the Garden Stillhouse, if Maeve wants to play that one. So just take about a minute. So there you can see the base of the still, and then the vertical part is what we call the swan neck, and then the line arm is coming off the swan neck into the condenser. Here you can see a plan view, the base and your swan neck. Here's your sight glass for looking in, and here is your boil taking place in the pot stills as you apply the heat. Now, the heating process, I suppose, again, if you go back 60, 70 years or more, would have been what we call direct fired stills. And that's where you would have coal underneath the pot still. And then obviously set fire to the coal, you have your fire, you start to heat up your still. And that's what we call direct fired stills. Now, very few places in the world have direct stills anymore. I know there's a limited number in Scotland. There might be a small number in Ireland as well. But we've moved probably in the mid-70s, and certainly when we moved to the new plant in 1975 to what we call indirect heating. So this is where you circulate the wash, for example, through a heat exchanger, and using gas as your indirect heating source, you basically heat up your wash gently, keeping recirculating. Your wash heats up and eventually starts to boil off, and you produce these vapors. So that's what we call indirect heating of stills. It's a lot safer, it's a lot easier to control, and you don't have any burn on, which was a big problem with direct fire stills.
We just have a few questions on the stills themselves here before we continue on with the distillation. How often are you doing the repairs on the stills, or how often would they need to be repaired and looked at?
Yeah, so we have a shutdown every sort of July for about 2 to 3 weeks. And that's where we shut down the whole operation, and we carry out lots of cleaning, maintenance, repairing seals, gaskets. And as part of that, we would do a thickness test on all our stills. So this is where we get in a specialist company, MetLab, and they would check the thickness of all the stills at certain points. And if they show signs of wear and tear and they need to be replaced or repaired, then that will go on a schedule, and we might schedule in for the following year, or if it's urgent, we would do it sooner. So basically, to answer your question, we do an inspection every year on all our pot stills and column stills.
Amazing. And then what would you say the average life of a still would be in terms of when it would have to be fully replaced?
We replaced the Barry Crockett stills were installed in 1975. There was sections of the still replaced and repaired over time, but we replaced the entire set of stills in 2020. So they last from 1975 to 2020.
Amazing.
There would have been sections replaced during that life cycle, though.
Amazing. And then actually quite a good question here. Would you say the cleaning would affect the flavor in any way, shape or form in terms of like when they're freshly cleaned versus like maybe a couple of months down the line?
No, it doesn't. Like our wash still would be clean. The wash still, which basically is your first step. So here you have a lot of, particular matter because it's the wash or like a beer. So they are cleaned probably every few days. We do a clean of the wash stills, which is really important to prevent any burn on in that still. But there are faint still and spirit still because of the spirit and the cleanliness involved. They don't need to be cleaned that often at all. But the wash still is regularly cleaned, but it has no effect whatsoever. None.
Okay, great to know. That's amazing. We can continue on, I think, for now.
Okay, so just to go back a bit there, I was talking a bit about reflux and the size and shape of the stills, right? So on the right-hand side there, you can see 3 stills, your wash still, your faint still, and your spirit still. I think the arrows went on there today. 1 second here.
It's automated, unfortunately. It's after going all on.
Okay, anyway. So anyway, we have a wash still, faint still, and spirit still. So if you take one of those stills, say the wash still, first of all, you have the base of the still. Then you have what we call the swan neck, which is the vertical piece. And then you have the line arm, which drops off there at an angle. So when you apply heat, your liquid, your wash, starts to increase in temperature. And eventually what's going to happen is you're going to have vapors coming off that. Eventually alcohol is going to start coming off at about 78 degrees Celsius. They rise up the swan neck. And what they do is they hit the side of the swan neck and the line arm, and they condense and they drop back down into the still again. That's what we call a reflux. So reflux is the return of condensate back into the pot still again. The higher the rate of reflux, so the more reflux you have, the lighter the spirit that come off after the condenser. Okay. So to give you an example, if you have a very tall pot still, like some places in Scotland would have very, very tall swan necks, you're going to have more reflux because you're going to have a higher surface area. So the vapors are rising up, they're hitting the surface of the swan neck, and they drop back down into the wash still again. And the taller the pot still, the lighter the spirit you get coming through from the condenser. And likewise then the squat or smaller the still, or the lower in height of the still, you're going to get a more, heavier distillate coming through from the condenser. So the height of the still, the shape of the still, the angle of the line arm, they all have a big effect on the style of distillate that you get off. Suffice to say, the 10 stills that we have here in Midleton, they're all the same shape, same size, same condensers, etc. And that ensures that we have a consistent style of distillate that we produce in Midleton. So hopefully that explains reflux and the shapes of the still and the importance of the shapes. So the majority of our whiskies here at Midleton are triple distilled. Everything on our main site is triple distilled. Now in the micro distillery, which we built back in 2015, 2016, we have played around with double distilled and triple distilled. So we do a little bit about a double distillation here. We have done some whiskies with Method Madness double distillation, but really everything on our main site is triple distilled. So how do we triple distill? So basically we take our wash, which Tommy produced earlier on at about 10% ABV, alcohol by volume, and we pump a batch of it into our wash still, okay, about 38,000 liters approximately. So what we do then is we boil that off and we produce what we call low wines, okay? So you can see the first green arrow going down to our low wines receiver. So then what we do is we take a batch of low wines and we put it into our second still, which is the faint still, and we start to boil off the alcohol. And then you can see the first red line, which is what we call our heads. So with our Fein still, we start to discriminate between different flavors and different compounds. So our heads basically are the first vapors that rise up the swannig, down the line arm, into the condenser. They're condensed down, and these are what we call, I suppose, volatile compounds that they boil off first, and they're what we call the heads. And we want to put them to one side. They contain some unwanted compounds that we don't want going through to the next stage of distillation. So after producing our heads, and that can be done on time or on alcohol, it could be 15 minutes, 20 minutes, depending on the type of whiskey we're producing. Then we move on to what we call the center cut. And that's put into our next tank, which is our Feins receiver down at the bottom there, our strong Feins. And we run our still until a certain cut point, and then we move on to what we call our tails, which is the second red arrow. And likewise, that's as well into our weak Feins receiver. So at this point, we have our strong Feins, and we pump that strong Feins into our final still, which is the spirit still. Here, we apply heat, we start to boil, and similarly to the Fein still, we have our cuts. We have our heads, we have our center cut, and we have our tails. Okay, and you can see the center cut there going into our new make spirit tank, and we end up with a new make spirit at about 84% alcohol by volume. So we've gone from a 10% ABV wash to now at an 84% ABV new make spirit. And then what we do is our weak Feins and our pot Feins, they're recycled into the next stages of distillation so that nothing is lost. As a distillate, and you can see there on the left-hand side, it's full-bodied, it's aromatic, it's quite spicy. As a taste profile, as Tommy mentioned earlier on, it's quite its mouthfeel is very silky, it's very smooth. And that's basically how we do our pot still, the triple distillation, okay? And I suppose the main way that we can produce what we call sub-styles of pot still spirit is by different cuts, okay? So in Midleton, we produce a light style of pot still, we produce a medium style, and we produce what we call a traditional heavy style. And the way we do that is the main way we do it is controlling the cuts. And to explain this, if you take our last still there, the spirit still, as I mentioned earlier on, you produce your heads, you boil those off first, you move on to your center cut, okay, which goes into your new make spirit tank. So your center cut could last, 7, 8, 9 hours, depending on the distillate that we're producing. If you prolong that center cut, okay, and you leave the last cut to as long as possible, you're going to end up with a heavier style of center cut, producing that traditional style of whiskey. If you shorten the center cut, in other words, if you leave out as much of the tails as possible, you're going to produce a lighter style of distillate. So by varying that center cut, the length of the center cut, you can control what style of whiskey you're producing. Is it light? Is it medium style? Or is it heavy? Now, I know that might be a little bit long-winded, but that's how we produce our different sub-styles of pot still whiskey. And they become really important later on then when we talk about how we produce our different brands, be it our spot whiskies, be it Jameson, be it Powers, because each of those brands have their own formulation.
That's really, it's great to actually dive into the nitty gritty and the stuff behind the scenes. These guys are great facts to pull out at a party and wow, you're friends with. We do have quite a few questions here just on volume. So I'm going to actually group two of these together because I feel like they semi-relate to each other. So someone here is asking about the volume difference before and after distillation. And then another person is asking in terms of why we only filled the pot still halfway. So I know we spoke about the cuts and the evaporation process and heads and tails. So maybe if you could just dive a little bit deeper in terms of the volume difference during the distillation process.
Yeah, so basically your wash comes in at 10%. So for example, if you have, let's say, to keep it simple, 10,000 liters of wash at 10%, you basically have 1,000 liters of alcohol. Okay. And then what you end up with in the spirit still, you have something at 84%. Okay. So the volume difference is significant. So you've gone from a 10% alcohol by volume down up to 84% alcohol by volume. So there's a significant volume difference between where you start and where you finish. So there's a lot of water being boiled off. You've pretty much 90% water to boil off and to get rid of. So the other question was, what was it, Maeve, again? Yeah.
The volume difference before and after, and then why you would fill the pot still only halfway.
Yeah, so I think I've covered the volume there. Yeah, like you say, you've 10,000 liters at 10%, you've 1,000 liters of alcohol, and then you end up with 84% ABV. So you'd end up with, say, 840 liters out of that. So it's a very significant difference in terms of volume, where you start and where you finish. So in terms of the size, so what you don't want to do here is obviously fill up the still too much. So in your wash still, we fill up to, depending on what we're producing, maybe 38 to 40,000 bulk, which is basically half the capacity. But the reason for that is that you need to control that boil. So you're going to get quite a vigorous boil happening when you start boiling off the alcohol. So you're going to get a lot of bubbling. We need to allow a head space for that reflux to take place as well. So you can't fill up the still up to maximum capacity. Obviously, it's going to go up your swan lake, and you're going to run out of space for boiling to take place and for reflux to take place. So you need to fill your pot still, half fill your pot still, to allow space for that to take place. So hopefully that makes sense.
Perfect. And then just in terms of what you mentioned at the micro distillery, would you say there is a significant difference in the loss of yield when you do a double distillate compared to a triple distillate?
Not really. Both would be like the way we do distillation here at Midleton. Both are pretty effective. I'm not sure is the question in terms of yield of, like, we recover all our alcohol, so there's very, very little goes to waste here. We recycle all our weak faints and our pot faints back in again. So it's all recovered. So the idea here is that you have as much recovery as possible. So there wouldn't be any waste as such. That doesn't happen.
Perfect. That's all the questions for right now. So if anybody else pop them in the chat, but other than that, you're welcome to continue.
Dave or Tommy?
Okay, thanks, Kev. So just to jump right back to the start, guys, Kevin obviously mentioned that we are making, more than one style of whiskey at Midleton, which is kind of unique. We touched on that last week in the kind of global whiskey industry. It's quite rare to have one distillery producing multiple spirit types. But what is great is that, we're all here today because of Jameson is a blended whiskey predominantly, but it's probably, quite different than, say, your kind of notion of a blended whiskey from some other countries. It's kind of grain to glass production and full production at one single distillery site. So we're producing the pot still whiskey. We're also producing the grain whiskey. And there's a few important differences on this side. So again, we're going to follow the process up to distillation, and then I'll hand over to Kevin. Some similarities, some big differences though. So I suppose the first big difference is the raw materials. So when we talked about pot still whiskey, we talked about barley in its raw or unmalted form and barley in its malted form. For the grain whiskey, we do use malted barley here. So it's the exact same, it's that Irish malted barley produced in the exact same manner. So that's our first ingredient for our grain whiskey. But the second ingredient is maize, or what you guys probably call corn. So the reason we use maize, I suppose, maize has a much higher sugar content than barley, over 70% kind of sugar or starch content. Higher sugar content means a higher yield, it's more efficient. And really the concept of grain whiskey we've kind of briefly mentioned it last week. You know, you're really going back 200 years. The advent of column stills. It was a very new style of whiskey, kind of a revolution in whiskey almost. The concept here is to produce kind of a higher strength spirit that has more of a light, delicate flavor profile. Maize or corn is really, really suited to column distillation. The high sugar content allows us to get like really good yields here. And we'll talk about that as we go through the process. So the main ingredient here is the maize or the corn. It's kind of a heavy majority there. And then you've got your malted barley as well. As I said, there's a lot of similarities here. So both of these are milled down, again, separately into flours. So you're essentially producing a corn flour. Like we do mill that fine. It's basically a corn flour. And again, your malted barley in a separate flour. There's a kind of an extra required stage here, which is called cooking. Essentially, because of the really high starch or kind of potential sugar content of the maize, it has to go through what's called a cooking system. Traditionally, we would use a higher temperature cooker, and as well as a lot of competitor distilleries probably use a higher temperature cooker system. We now use what's called a lower temperature cooker, much more efficient, particularly from kind of an energy point of view. So essentially, we mix the maize grist or flour with kind of a hot water. We produce what's called a slurry. We cook it to 88 degrees Celsius, and then that does what we call gelatinization. Think of it as almost kind of like popping open or bursting open these starch granules. So then they're kind of accessible to the enzymes. And the enzymes are really important on this side as well. So we basically gelatinize the starch, cool it down. There's a lot of the natural enzymes here. When we add in the malt, they would be killed kind of if you go above about 65 degrees Celsius. So you mix it in after it's been cooled down. Mixing those together, again, this is where we're going to have conversion. So it goes into what's called a converter can. And again, we do add the extra enzymes here as well, just to make sure we get full conversion. And what we have left here then is a liquid. We still have all of the solid matter. And I suppose one really important point on this side is that we don't actually filter out the solid matter at this stage. So there's no mash filters or anything like that. It's kind of like a soupy kind of consistency, I suppose, if you want to think of it that way. We don't filter it out at this stage because, as Kevin's going to go through in 2 slides' time, because we use column stills, you can do what's called kind of grains in distillation here, where solids go in with the liquid. And Kevin will talk about how they're kind of removed in that process. But think of it, solids are still in the mix at this stage. We do need to ferment. There's a lot of similarity here, so I won't go in the kind of same detail. It'll just be way too much repetition. But again, we're using Saccharomyces cerevisiae. It's that distiller's yeast. It's doing the same job. It's breaking down sugars, about half into CO2, about half into alcohol. I suppose there's a few kind of key differences here. We have a lot more sugar content. Yeast, it's a living organism. It's working at breaking these down, consuming these sugars. Because there's more sugar, it's going to take a little bit longer. So whereas it was kind of 60 to 80 hours maybe on the pot still side making our wash, here it's a little bit longer, more in the 80 to 100 hour bracket. Takes a little bit longer to break down the sugar, but the added advantage or the benefit to us is more sugar means more alcohol. So the final kind of product at this stage, we don't call it wash. To distinguish the two, we actually call it a beer on this side. And we can reach up to about 15% ABV here. It could be kind of 13 to 15% ABV. And again, that's down to the higher sugar content of the maize. It's a very different beer. Just like the final whiskey is going to be quite different than, say, the pot still whiskey. We're going to have a different composition here when it comes to the esters and the aldehydes. So it will be, very much a different flavor profile than the wash and the pot still side. But in the same regard, it is a mixture of alcohols and congeners, kind of flavor compounds, some that we want, some that we don't want. So at the same time here, we have to distill it. But for our grain whiskey, we're talking about a totally different type of distillation, column or continuous distillation. So Kevin's going to talk through that.
Okay. Any questions so far, Maeve? We okay?
We're all good for questions right now.
Oh, good. So in terms of column stills, we have 3 column stills in the Barry Crockett Still House. So if you look at the right-hand side there, that photograph, they are the Barry Crockett column stills, or it's one of the column stills in the Barry Crockett Still House. And that goes back to 1975. And just maybe take note there that the majority of the column is stainless steel, including the plates on the inside, but there is copper sections. And again, these copper sections are really important in the extraction of sulfur compounds. And then on the left-hand side, we have our newer columns, which were installed in 2013, 2014, as part of a Midleton expansion. Again, these are stainless steel. And then we have sections of those columns that have what we call copper packing. So this is like pieces of copper that are inside in sections of the column. And basically, again, it interacts with the vapor and the spirit to extract sulfur compounds. So the old columns used to have sections. The newer columns have what we call packing. So they're photographs of the continuous stills. Just to explain the size, maybe the next photograph will show that. That photograph there, the tall building, it's about 44 meters in height. That'll give you, even if you look at the building to the front there, the Academy building, where actually we're sitting at the moment. You can see that blue door. We're just inside that blue door. So that's the Academy. So in the background, then the tall building is the new column building, going back to 2013, 2014. And then just behind that, you have the older columns, the Barry Crockett Still House, where you have the old columns going back to 1975. So these columns are very, very large, with the new ones up to about 44 meters in height. So how did it work? Again, I've mentioned that the newer columns are stainless steel with copper packing. And what you have is a series of plates inside in the column. So if you look at there's 3 stages to the distillation process. We have a beer column, we have an ED column, extractive distillation column, and we have an EDR column, which is extractive distillation rectification column. Okay. And in each of these columns, we're increasing the strength, and we end up with a spirit at about 94.5% ABV. So if you remember back to the pot distillate coming off the third still, it was about 84%. Here we have distillate at about 94%. Okay. So again, it's very much different aroma, different style, different flavor. And I'll explain that in a few minutes. So what happens with the beer column, as an example, is we basically pump in the beer about maybe halfway up the column. The beer starts flowing down these plates, and then we have a steam coming up from the bottom. So basically, you have steam rising, you have the beer or the wash going down, and then what we have is separation taking place. You've like each of those plates is almost like a mini pot still, a mini distillation unit in itself. So you have this separation taking place. So you go from your beer column, which starts off at about 13, 14, up to 15% alcohol by volume. And then the third still, it comes off at about 94.5% ABV. As a spirit, when it comes off that still, and when you nose it, it's as a distillate, it's quite light. It has lovely floral notes, some herbal notes, maybe cut grass, a little touch of toffee or butterscotch as well. But it's very, very distinctive and very different in comparison to the pot distillate. Just to mention as well that we do produce 3 styles of grain spirit at Midleton. Number 1, we have our signature grain, and that's made from the mash bill that Tommy has described, which is maize and malted barley, triple distilled in our new columns mostly. We also then produce a smaller batch grain whiskey, which has a similar mash bill that Tommy described, maize and malted barley, but that's distilled in the original columns, the Barry Crockett Still House. Okay, and there's different settings, there's different draw-offs, producing a different style of spirit. And then the third style has actually a mash bill of malted barley and barley, similar to the pot distillation. And that is also distilled in the Barry Crockett original stills. And that gives quite a different flavor profile as well. As a distillate, it has a lovely enhanced butterscotch toffee note. So if you compare that, what we call select batch or small batch grain with our signature grain, it is much sweeter. There's a lovely butterscotch note. And that particular style of grain whiskey actually goes into Jameson Black Barrel. So when you nose Jameson Black Barley and you get that lovely toffee, vanilla, butterscotch note, a lot of that flavor is driven by the style of grain whiskey used in Jameson Black Barrel. So hopefully that makes sense. Any questions on that one?
We have a question here kind of more referring to the wash and if that would be potable, safe to drink straight off the bat. It also says in brackets enjoyable. So, I mean, I think you can speak to if it's actually safe to drink and if that would be even enjoyable to drink.
Yeah. Yes, it would be safe to drink, but it wouldn't be that enjoyable.
That's what I was going to say.
So really, it's very much like it's like a beer. But for example, the wash that goes into our column distillation is grains in. So it's basically full of all your spent grains. It's basically grains in. It wouldn't be that palatable, to be honest. And that's why the separation takes place in those columns. If you compare it to our wash from the batch side or our pot side, again, that's at about 10% alcohol. It doesn't have much of those spent grains because they're already filtered out using the mash filter. But again, it would be quite a sweet beer, quite heavy, very aromatic, lots of esters. Is it safe? Yes, it would, but you wouldn't drink much of it, to be honest. You could sample it, take a mouthful, get a feel for it, but you wouldn't drink too much of it, no.
That's perfect. That's what I thought. Often, sometimes the safe part and then the enjoyable part comes through the extra processing that we do. So
exactly.
That's perfect. All good on questions right now. So thank you so much.
This one.
Brilliant. Thanks, Seb. So I suppose just to kind of summarize, guys, and just to make sure there's no confusion, like what we've kind of covered today, Midleton is producing two very distinct spirit types under the one roof or in the one campus. It's almost like two distilleries in one. So just so there's no confusion, we make pot still spirit, and I know it's not on the screen there, but again, from a grains point of view, the pot still spirit is produced from barley. You can think of it as raw or unmalted barley. So it's made from barley and malted barley. We essentially brew those into a wash, which is like a beer at about 10% alcohol. We then triple distill it in the copper pots. So it's not a legal requirement to triple distill. We mentioned that last week. Yes, most Irish whiskey is triple distilled. Yes, essentially all the core bottlings from Midleton are triple distilled, but it's not a legal requirement. But we're triple distilling in the copper pots. And again, the copper being essential to the kind of purification or the rectification. After 3 distillations, we're taking it up to 84% alcohol by volume, thereabouts. It's a clear spirit at that stage. It's nothing like a vodka or anything, nothing like that. So it's quite aromatic. There's a nice amount of kind of spice on the palate. And again, it's going to have that lovely silky texture on the palate. Really nice mouthfeel or texture or silkiness. And because it has quite a robust style of its own at this stage, it's essentially suitable to go into all cask types. Again, this isn't a legal thing. It's not part of the GI or anything. But from our point of view, we obviously need to decide what spirits go best in what casks. We'll talk all about that next week. But just at this stage, you can see that the pot still spirit, because it's quite robust, it's less likely to be kind of overpowered or clash with some of the more flavor, some kind of fragrant cask types. So essentially, we can fill that into all the different casks. On the other side of production, then, we produce grain spirit. Big differences here when it comes to the raw materials. We're using maize, or what you guys might call corn, and also some of the malted barley. Again, a heavy majority of maize. We produce what we call a beer at that stage, and we're up to kind of 13, 14, 15% alcohol. We then distill this in the column stills because it's a very different type of system, much more efficient. We're bringing it right the way up to about 94.5%. And again, I'm going all over this, particularly for the 50 of you who are doing the exams, bear in mind, this is all key information. But we're bringing it up to 94.5%. Sometimes people might assume, is that neutral spirit? Is that what becomes vodka or something? No. So a legal limitation under Irish whiskey law is we can't distill above 94.8%. Because if you go over 94.8, then you're kind of getting into the danger zone. You're becoming quite close to neutral spirit. You're probably looking at more kind of 96% up to be neutral. You're getting into that kind of dangerous territory. We stop well below that threshold. And as a result, we are retaining congeners, so like flavor compounds. So it's not neutral spirit that we're producing. It's triple distilled grain spirit. As a result, it's light, it's delicate, floral, kind of fragrant. And, because it has a very different and distinct character, because it is that little bit lighter and more delicate, it maybe does have the potential to be overpowered by certain kind of, very fragrant, very flavorsome cask types. We tend to only really fill that into bourbon barrels, which we'll talk about next week. One asterisk there, we are all here today kind of particularly because of Jameson Black Barrel. So as you can imagine, Jameson Black Barrel might feature heavily in any questions and exams. So Jameson Black Barrel is a blend. It is a blend of pot still and grain spirit. But as Kevin mentioned, we do produce this select batch grain spirit that goes into Black Barrel. What's the big difference there? The grains that are used initially. So the select batch grain spirit that goes into Black Barrel, the initial grains there are barley and malted barley. So like Kevin says, you're starting off kind of with the same mix as you would associate with pot still spirit, but this time we are triple distilling it in the Barry Crockett Still House column stills. Again, like Kevin mentioned, different takeoffs, slightly different setup with the trays and stuff. So it's going to produce a different spirit. That select batch grain spirit is a little bit sweeter, more full-bodied, particularly that lovely kind of butterscotch aroma coming through. So let's bear that in mind. It's obviously important. Another important point, just to quickly mention, the spirits are not mixed at this stage. So we'll go into blending in 2 weeks' time. We'll do that in a lot of detail. Blending, think of that as being like the final stage before bottling. These spirits will individually go into casks, and then the blending will take place after they come back out of the casks. So look, if there's any kind of last questions there, absolutely shout them out. But
just maybe Maeve, the question previously on volumes, if you use an example here, like if you start off again with 10,000 liters, just take it at 15%. So you have 1,500 liters of alcohol to extract. So at 94%, then you'd end up with somewhere like, 1,600 bulk liters at, say, 94.5%. So you go from, say, 10,000 liters down to roughly 1,600 liters in this particular case. I suppose that might be the question that was asked originally, I'd say.
Okay, great.
Is that clear?
That answers it perfectly. Is there any other questions, guys, in the chat? Speak now or forever hold your peace. We've got two masterminds on here, so let's pick at their brains. Well, I'll give it a minute or two, but just as a reminder, we do have next week's classes delving deep into the maturation process, which is super interesting part of the Irish whiskey production. So make sure that you are logging back on for that. Before we wrap up, any last questions? I think we're good. You obviously are extremely good at your jobs, guys, because everyone's speechless. Oh, no, I spoke too soon. How soon are we going to be able to watch again? What a fantastic question. So we have a private class tomorrow if you're part of the cohort, and then I believe the next public class will be this day next week at the same time. And we have one more. Just to verify, Jameson's Black Barrel grain whiskey is made without corn.
Yeah, one of Black Barrel is it's probably one of our most complex whiskies. We have 14 different parcels of whiskey, would you believe, that goes into Black Barrel. 14 different parcels between pot whiskey, between grain whiskey. But I suppose we do use some signature grain in Black Barrel, but the main grain whiskey that we use and the main grain, I suppose, flavor driver is that particular select batch grain, which is made from barley and malted barley.
Brilliant, thank you. And here's a good one, just to speak to kind of the sustainability aspect. Besides using the byproduct for animal feed and the low pressure cookers, is there any other aspects that you'd like to highlight in terms of sustainability parts of production?
Oh yes.
I'll stay here for an hour.
How long do we have? Oh my God. So I suppose sustainability is a huge part of what we do here in Midleton. It's a project that we've been up and running for probably 15, 16 years now. It covers all areas, Maeve, really. Even if we just focus on water, for example, and water usage. We've been working on projects for probably 20 years or more now in reducing the amount of water that we use as part of distillation. Since I joined what, in 1998, I'd say we have halved the amount of water that we need now in the production process. That's through technology, it's through recycling, it's through reusing, it's through controlling, and even more recently in the last year, we've added water recovery from our warehouse roofs. So that's basically where we recover water, that rainwater from our runoff from our warehouses, and we basically treat that and we use that then in the process as well. So we're reusing and recycling all that water. So massive recovery going on in water. Energy consumption, massive projects over the last number of years in terms of recovering and reducing the amount of energy that we use in the distillation process. Did a very large project about 2-3 years ago where we installed what we call MVR, or mechanical vapor recompression, in the pot stills. So that is where we use all the waste heat that comes off our pot stills. We re-energize that heat by pressurizing it, and then we produce high pressure steam and we recycle that back into the process again. So basically what you have is recycling waste heat back in to heat up the stills again. So it's really like a heat recovery process. The list goes on in terms of our barley and malted barley is sourced, locally in Ireland, probably within maybe 100 kilometers of the distillery. We can't grow maize in Ireland, so our maize is sourced in France. But between sourcing our maize and our barley and our malt barley, we have a significant amount of projects going on in terms of, agriculture, biodiversity. We offer actually a premium to our barley growers in Ireland for doing lots of biodiversity projects on their farm. So we offer a premium to those. I think we've over 200 farmers on that particular scheme. So I seriously, I could talk here for hours on the projects, but between energy, water, cereals, the guys next week will talk about barrels and oak and where we source our oak and getting certified oak. I suppose we put a lot of energy into our sustainability and our responsibility, and it's something that I would be particularly passionate about. So hopefully that answers some of the questions.
No, that's brilliant. I know that we have a ton of efforts here in terms of sustainability, so thank you for giving some of many examples that we do have. We have a question here in terms of our rye style whiskey and Irish whiskey, and if that's something we have, is that something associated with Irish whiskey? If you kind of speak to that slightly.
Yeah, so rye. We've done rye whiskey. We do a Powers rye. So it's made from 100% rye. So you have unmalted rye and malted rye. It's distilled on our original Barry Crockett column stills. It's a fantastic whiskey. And we've also done rye as part of our Method of Madness. We've done a rye and malt whiskey. So we've done rye. There is lots of examples of rye whiskey in Ireland. So basically, you call it Irish whiskey, and then you basically clarify that it's rye. So yeah, we've done lots of it. And as a whiskey, and whoever's asked the question probably knows that, I suppose, as a whiskey style, it's really spicy, lots of clove, really, really aromatic, and a really, really spicy flavor coming off that particular whiskey.
Amazing. Thank you so much. Yeah, we're super innovative in terms of Irish and our styles of whiskey. So great to touch on what the what the other ones are. We have a great question here. We don't know now if we can get this information out there, but is there any special releases we can expect in the future that you're not bound to secrecy over? You can let our friends here in on the inside scoop.
Yeah, so we've a redbreast coming out shortly, a variant on redbreast. I think we're safe enough to mention that. It's Muscatel, so that's coming out next month. We'll have the Midleton Very Rare Vintage 26. I'm just working on that at the moment. Hope to have the final prototype in maybe a week or two. So that vintage will be released in February. So looking forward to that. So they're the two imminent ones, really, Maeve. And then I suppose we've lots of other stuff in warehouse, lots of barrels, lots of different distillates that are sleeping away in the warehouse. They're progressing well for future releases, but hopefully that will give some people an insight.
Great, we've got some inside scoop there, and I actually got to try the Muscatel only about 2 weeks ago, and I highly recommend to everyone here to get your hands on it because it was a nice little treat. We have one final question, I believe. Is triple distilling more of a tradition due to the level of early technology, or would you say with advanced technology there'd be a way to cut it out? Is it still necessary? Will it be in the future of Irish whiskey, would you say?
Yeah, well, for us at Midleton, it's what we do, and the triple distillation process is really important in terms of how we do it, the cuts. So it's part of what we do. It won't change. We do some double distillation on our micro distillery. There is quite a difference between double distillation and triple distillation. But in terms of our main distillery, in terms of our main brands, so I don't see that changing. There's different technologies and different ways of doing things, but in terms of the principle of triple distillation, wash still, fade still, spirit still, that won't change.
Super. Thank you so much. That is all the questions that we do have. So I guess I just want to say a big thank you to both Kevin and Tommy for spending their Tuesday afternoon. I know it's a later time in Ireland, so I really appreciate you hopping on. And thank you so much to everyone who has decided to spend some of their Tuesday here with us. If you did enjoy this class, show us a bit of love, send some comments, like button, love button, wherever you're coming from, hit it. Also, make sure that you're following us on our Facebook and YouTube. There's tons of classes like this. It's an amazing resource. It's a great way to, learn a little bit more about something you're interested in, have some fun facts up your sleeve, everything like that. We also have on Instagram PGXCW and Lush Life Productions, and you can find out what's coming up next. Again, we asked earlier about when you can next watch. That'll give you a nice reminder if you're following those. It should pop up on your feed. You can find out anything more about Jameson at Jameson US. I am also on Instagram at Whiskey with Maeve. If you ever have any hard-hitting questions you need answers to ASAP, send me a message. I am happy to answer them, and if I can't answer them, I will find the answer for you. I want to say a big thank you as well to Jameson Black Barrel for actually making this entire course happen and allowing it to be both a private certification program but also a public knowledge area as well. So it's great to have this resources and to get FaceTime with Kevin and Tommy today. And as I said, we're diving deep into maturation next week, so please come back and join. Other than that, thank you so much, and I will free you for this Tuesday afternoon. Enjoy.
See you, everybody.
Bye.
Bye.